Okay guys, we're going to finish up the packet with this set of videos. We're going to be covering the word problems on pages 16 through 19. We're not going to do all these problems. We're going to skip a few of them. So just kind of pay attention as you're going through this video. For a lot of the examples, I'm going to set up the problems with you and then and have you solve them on your own. And then for some of the examples, we'll work through the entire problem. Okay, so quadratic applications is just a really fancy way to say word problems, which we tend to dread, but they're not as bad as we would think. Okay, so we're going to go through several types of problems. The first problem is an area problem. It's a rectangle model. It says the width of a rectangle is 6 meters less than the length. So we're going to draw our rectangle. The length we're going to call x, okay? And the width is 6 less than that, so it's x minus 6. So like if this was 10, this would be 10 minus 6, and so on. We also know that the area is 112. And I know from geometry that for a rectangle, length times width equals area. So x times x minus 6 equals 112. So I have a quadratic equation. Now, I cannot solve something that says x times x minus 6 equals 112 without doing some manipulation. So the first thing you're going to do after you set up the problem is you're going to distribute it. So you get x squared minus 6x equals 112. And then we're going to solve this problem, and we have several different ways to solve it. This one's kind of set up to where completing the square would be pretty easy, so that's what I'm going to do. You could also solve this using the quadratic formula by subtracting 112 and then plugging those values in, or you could factor it, but I'm going to go ahead and do completing the square. So since I have negative 6 here, I'm going to divide it by 2, and I get negative 3. And the negative 3 squared is 9, so I'm going to add 9. Get x minus 3 squared equals 121. Remember, this number is half of the 6. I'm going to take the square root of both sides. And this time, I'm going to consider the positive case only. And I'll show you why in just a minute. So I get x minus 3 equals 11. And then I add 3. And I get x equals 14. So that's going to be my length, which is 14. And then my width would be 8. Now, why did I consider the positive case only? The reason why is because I'm measuring something. So if I try to figure out length, I've only got positive numbers. I can't have negative values. Okay, if they ask us for the dimensions, they want to know both the length and the width. So x is length, which is 14 meters, and width is 8 meters. And to check my work, I could say 14 times 8, which is 112, and then 14 minus 6 is 8. So I know it fits everything I needed it to fit. Okay, number 2 is a similar type of problem. It says, sorry about that, the length of the rectangle is 1 foot more than twice the width. The area is 300. So you're going to draw a shape again. The width is going to be your x, and the length is going to be 2x plus 1, because it's 1 more than twice the width. So you're going to use the same formula for area. Area equals length times width. We also know the area is 300. So 2x plus 1 times x equals 300. And then you distribute that out. 2x squared plus x equals 300. So you have a quadratic function. Now this one I would solve with the quadratic formula. Or you could even solve it with graphing. I would not try to complete the square on this one because of the 2 in front. So if you want to solve it with the quadratic formula, you do 2x squared plus x minus 300 equals 0. You're going to solve that out, and then you're going to take the positive case only because it's a length, so it can only be positive. Okay, so number 2, you're going to finish working out on your own. So you've got this set up, you're going to solve it. Number 3 is another one I want you to work on your own. Again, you've got a rectangle. You know the area equals length times width. They tell us the area is 65. We also know that the dimensions are x plus 6 and x minus 2. So you're going to set it up. You're going to say x plus 6, x minus 2 equals 65. So you distribute all that out, put it in standard form, which means that it equals 0, and then solve. So that's going to be your assignment on that. Distribute it out, get it in standard form, and then solve. Okay. Number 4 is another problem where we have dimension. It is a triangle problem. So we're still looking at area, but our formula is different. So if you remember the area of a triangle, it says the base of a triangle is 7 less than twice its height. So if we call the height x, then the base would be 2x minus 7. And the area equals 102. We also know the formula for area is 1/2 times base times height. So to set this one up, you're going to do 1/2 times x times 2x minus 7 equals 102. Now, it does not matter on these types of problems the order you write this stuff in over here. I could have written 1/2 times 2x minus 7 times x. It would work out. Okay, one thing about fractions and the way this problem looks, dealing with a half, if I distribute this out, I end up with 7/2, which I don't want. So I'm going to multiply both sides by 2. And I'm going to show you what's going to happen there. You're going to have x times 2x minus 7 equals 204. You distribute this, you get 2x squared minus 7x equals 204. And then if I